Okay, so in the previous video we talked about how to actually calculate a general term or find out a general term of a number sequence and then use it to calculate any nth term of that sequence. So in this video we'll be actually doing one more example because I feel that the number sequence is the toughest of all the topics of O-level mathematics. The reason that I believe that is because it does not have a general rule, it does not have a general principle or a solution or a technique to solve you know any problem. You just need to have a very good uh, you know mm, logic or very good IQ in order to solve problems of number sequence. You need to be a little bit more clever to solve, and you can expect anybody to be not able to solve a simple number sequence problem because there is no general principle to solve number sequence problems, although there are some tricks and hacks that you may learn in order to make your work easy, but you never know. So let me actually have a chance to share my technique. How do I solve number sequence problems? So let's actually develop a sequence. For example, I can develop a sequence uh, like this: 3 and let's say 6, right? And then let's say 11, right? And then let's say 18, let's say 27, let's say 38, let's say 51. Right, so this is a sequence. At first you could say, okay, 3, 6, then there should be 9. Why is it an 11 here? Or you could say, okay, it starts to increase exponentially then. How do I find the next term of this sequence? Or maybe how do I find the, for example, 10th term of this sequence? What is the 10th term of this sequence? Given that this is the first term, this is the second, this is the third, fourth, fifth, sixth, seventh, what would be the eighth term, and what would be the 10th term, right? So first thing that you need to notice about this sequence is that it is not linear. Like you added a 3 to get 6, then you added a 5 to get 11, then you added a 7 to get 18, then you added a 9 to get 27, then you added a 11 to get to 38, and then you added a 13 to get to 51. So by watching what you need to add into every in order to get next term, we can see that 3, 5, 7, 9, 11, 13, then we must add 15 in order to get the next term. So that can tell us, okay, 51 plus 15 is 66, right? So 66 is the eighth term. But what would be the 10th term, or what could be, for example, the 20th term? Let's talk about the 20th term, right? So we can't be just doing this exercise all the way up till 20. We could have been asked about 120th term, so we can't be actually going all the way to 120 for that. We need to find a general term that can that actually gives us a formula, so that we just need to add we can just find any nth term directly from that. So this exercise is related to that. So we can see that this is not linear because the term that we are adding in every term to get next term is increasing. But as you can see, this term and this term has a difference of 2. This term and this term has a difference of 2, 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 and so on. So you can see that this is a second order linear term. Like that's what I like to call it. There's no some official way to call it like that, but since I'm sharing my technique, I would call it like that, the second order number sequence. So you can see that the difference in the terms of the sequence that are used to add into each of the terms in order to get the next term. What I mean to say is that I don't want to confuse you guys. I just want to say that you can see that the terms that you add are not same, but the terms that you add have a difference that is common now. So it is not common, the term that you're adding, they are different numbers, but the difference in those numbers is now common. So there has to be an n square involved in that. If these numbers were not 2, they were also increased, and then you found out the numbers that actually you need to add in order to get these numbers. And if those numbers were common, then that would be a third order, and you would just add a cube. But this is since the common terms comes right at the second order. These terms are not common; they're not same, but these terms are same. So there has to be an n square involved in that, right? So let's see if we can add, if we can, use like if we can draw a table and then see if we get the the result the required results or not. So if we put n is equal to 1, what do we get? In n square we get 1, right? So we can see that the first term is not 1, it is 3. So all we need to do is add a 2 to it in order to get 3. If we put n is equal to 2, we get n square that is equal to 2 square, which is 4. So we get a 4 in but the second term is not 4, it is 6. So we can see that we need to add a 2 into it again in order to get that. The third term in n square would be 9, right? But the third term is not 9, it is 11. So we need to we need to add a 2 to it, and we can observe that this actually works. In the fourth term, if we take 4 squared, which is 16, n squared would be 16, but again we need to add a 2 into it in order to get the fourth term, which is 18. So n squared is valid, but this 2 is missing. We need to add 2 into all of these terms in order to get to the sequence that we are required. So all we just need to do is use this 2 plus n squared. So 2 plus n squared is the general term of this sequence, because whatever the number we take, for example, we take 5, we can square it, we get 25, and then add 2, we get 27. So 2 plus n squared. So all you need to do is to see if it is first order number sequence, second order, third order. Like you can just observe by doing this. I can give you an example of third order as well, but let's actually finish the job here first. So 2 plus n squared is actually what you get, and the 20th term would be just 20 squared, which is 400, plus 2, which is 402, right? So 20th term would be 402. Let me give you an example of a third order. So third order would be just simply the numbers that are cubes, for example, like 1, like 8, like 27, like 64, and 125. You can see that the this sequence is simply the cube of all the numbers. One cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. The difference in these 7, and the difference here is, for example, 19, right? And 27 and 64, 37, 47, 57, and then 7. So 37. I hope I'm not messing up my mathematics here. 64, and that would be 61, I believe, right? So these are the differences in these numbers. And then the differences in these numbers, 7 and 19, the difference is of 12, right? 19 minus 7 is 12, right? And then uh, 37 minus 19, 20, 29, 39, and it is, we can see 18, right? 37, 60, 61, 47, 57, and then we can see it is 24. So again, in the second term, like we had 2 common here, but we did not get a common number here. But then we need to find the difference further. The difference in 12 and 18 is 6. Difference is 18 and 24 is also 6. We got a common result. So we got this common term in the third iteration or calculation. In the third, this is the first sequence, this is second, like this is the actual sequence, this is the difference of the sequence, which is the first order. If this was common, we would have a linear sequence and n would have been there. If this term was common, we would have a second order and we could get an n square like we had in this sequence, and we got the actual common difference in the third order, and that indicates us there has to be an n cube involved. In fact, we could see that these are just the cubes of the numbers. So this is an exponential sequence that involves a cubic function, right? So you can always use this technique in order to find out whether the function is linear, exponential, second order, third order, fourth order, whatever. And then you just need to perform this exercise. You just need to make a table and then see what number you need to add into each of those terms in order to get that sequence, and that can help you get to that sequence in the quickest way possible. I hope I didn't confuse you and help you understand number sequences and solve problems using various techniques.